Hello everyone, I am Jerry, the protagonist, and tonight I'll be looking at one of the Try Hack Me Room's intro to endpoint security. Now, usually on this channel I have been going through lots of hacking tutorials and really into pen testing as a career choice, but my day-to-day job now requires me to learn more about the defensive side of security. And so I wanted to start going through some of the SOC Level 1 course on Try Hack Me, as well as some of the Red Team Challenges course later on. So for this stream, we're going to be going through the Intro to Endpoint Security module on Try Hack Me. So if you have a Try Hack Me account, you can go on with it with me. If not, well, just join me as I learn a little bit more about endpoint security. So this room is all about endpoint security, the fundamentals, methodology, tooling, and for any kind of security monitoring. It has been a long time since I have streamed last, and since I've been active, I have been busy at work. So welcome to the stream, and it's glad to be with you guys. So let's get into it. It says, in this room, we will introduce the fundamentals of endpoint security monitoring, essential tools, and a higher level methodology. This room gives an overview of determining a malicious activity from an endpoint and mapping its related events. To start with, we will tackle the following topics to build a stepping stone on how to deal with endpoint security monitoring, which include endpoint security fundamentals, endpoint logging and monitoring, endpoint log analysis. At the end of this room, we will have a threat simulation wherein you need to investigate and remediate the infected machines. This activity may require you first to understand the fundamentals of endpoint security monitoring to complete it. Now let's deep dive into the basics of endpoint security. If you don't know what an endpoint is, it's basically any kind of computer or device that's connected to a network in an organization. That's what's considered an endpoint. So some endpoint security fundamentals. Let's look at some core Windows processes. Before we deal with learning how to deep dive into endpoint logs, we first need to learn the fundamentals of how the Windows operating system works. Without prior knowledge, differentiating an outlier from a haystack of events could be problematic. To learn more about core Windows processes, a built-in Windows tool named Task Manager may aid us in understanding the underlying process inside a Windows machine. Task Manager is a built-in GUI-based Windows utility that allows users to see what is running on the Windows system. It also provides information on resource usage, such as how much each process utilizes CPU and memory. When a program is not responding, the Task Manager is used to terminate the process. That's usually what you do when you press Control-Alt-Delete on your system. It opens up Task Manager, and then you're able to stop, kill processes, see what's running, see what's using up your resources. And it usually looks like this. A task manager provides some of the core Windows processes running in the background. Below is a summary of running processes that are considered normal behavior. Note, this character symbol represents a parent-child relationship. So the system is the parent of smss.exe. So we have system smss.exe, csrss.exe, wininit.exe, wininit, and services, and then services svc host.exe, lsas, winlogon, and explorer. These are the main things that you'll see, and going into any kind of SOC environment, you will see these a lot in your logs. You'll be just scrolling through a bunch of those when you're investigating any kind of incident. In addition, the processes with no depiction of a parent-child relationship should not have a parent process under normal circumstances, except for the system process, which should only have system idle process as its parent process. I'm guessing this 0 is the process ID number. You may refer to the Core Windows Processes room to learn more about this topic, which I think at some point we'll go through later. Sysinternals. With the prior knowledge of Core Windows processes, we can now proceed to discuss the available toolset for analyzing running artifacts in the backend of a Windows machine. The Sysinternals tools are a compilation of over 70 plus Windows-based tools. Each of the tools falls into one of the following categories: file and disk utilities, network utilities, process utilities, security utilities, system information, and miscellaneous. We will introduce two of the most used sysinternal tools for endpoint investigation to this task: TCP View, Networking Utility View, and Process Explorer, which is a process utility tool. TCP View is a Windows program that will show you detailed listings of all TCP and UDP endpoints on your system, including the local and remote addresses and state of TCP connections. On a Windows Server 2008, Vista, and XP, TCP View also reports the name of the process that owns the endpoint. TCP View provides a more informative and conveniently presented subset of the NetStat program that ships with Windows. The TCP View download includes TCP vcon, a command line version of the same functionality. As shown above, every connection initiated by a process is listed by the tool, which may aid in correlating the network events executed concurrently. Well, that's pretty cool. So here we have the process, the ID number, the local address, the port, and then if it's connecting to any remote address or remote port, that should be listed here, and then the protocol that's being used. Process Explorer. The Process Explorer display consists of two sub-windows. The top window always shows a list of currently active processes, including the name of their owning accounts, whereas the information displayed in the bottom window depends on the mode that Process Explorer is in. If it is in handle mode, you'll see that the handles that the process selected in the top window has opened. If Process Explorer is in DLL mode, you'll see the DLLs and memory mapped files that the process has loaded. So we have the service, the display name that we know the service by, and then where it is on the system here. Process Explorer enables you to inspect the details of running process, such as associated services, invoked network traffic, handles such as files or directories open, DLLs, and memory mapped files loaded. If you've ever used Process Explorer, you will know that it can become quite a mess quite quickly because it captures all of the process information. So you only want it to be open for maybe like 5-10 minutes to capture, you know, if you're doing some malware traffic analysis or trying to understand how a piece of malware is working on a system, what it's doing, how is it opening stuff up. You only want to run it for like maybe 10 minutes because if not, it just produces so many logs. But yeah. What is the normal parent process of services exe? I think that was WinInit. Yep. WinInit. What is the name of the network utility tool introduced in this task? That was TCP View. Yep. All right, on to endpoint logging and monitoring. From the previous tasks, we have learned basic knowledge about the Windows operating system in terms of baseline processes and essential tools to analyze events and artifacts running on the machine. However, this only limits us from observing real-time events. With this, we will introduce the importance of endpoint logging, which enables us to audit significant events across different endpoints, collect and aggregate them for searching capabilities, and better automate the detection of anomalies. Windows event logs. Windows event logs are not text files that can be viewed using a text editor. However, the raw data can be translated into XML using the Windows API. The events in these log files are stored in a proprietary binary format with a EVT or EVTX extension. The log files with the EVTX extension typically reside in the Windows System 32 WinEvent logs. Hang on a second. Just had a message I needed to respond to. There are three main ways of accessing these event logs within a Windows system: the event viewer, evtutil.exe, and get win event, which is pretty cool because you can do it from the GUI, you can do it from the command line, or you can do it from PowerShell. An example image of logs viewed using event viewer tool is shown below. So here we have the structure of all the logs, the individual logs themselves, and then some actions that can be performed. Usually when you click on any of these, you'll have more information down here on the particular event that was occurring. Sysmon. Sysmon is a tool used to monitor and log events on Windows. It is commonly used by enterprises as part of their monitoring and logging solutions. As part of the Windows Sysinternals package, Sysmon is similar to Windows event logs with further detail and granular control. Sysmon gathers detailed and high-quality logs as well as event tracing that assists in identifying anomalies in your environment. It is commonly used with a security information and event management system, a SIEM, or other log parsing solutions that aggregate, filter, and visualize events. Lastly, Sysmon includes 27 types of event IDs, all of which can be used within the required configuration file to specify how the event should be handled and analyzed. An excellent example of a configuration file auditing different event IDs created by Swift on Security is linked here. The image below shows a sample set of Sysmon logs using an event viewer. So we have the level of severity, the time, the source of the logs, and then what kind of events they were, and the categories. Let's have a look at this. Function as a great starting point for system change configuration. So let's have a look at this. So here we have things like process create, on match, exclude. So this means that it will exclude them from being logged or being connected. So things like svc host -k. This is like typical startup information for different services. Go away. This is pretty cool. Yeah, so this is a typical one that I've seen on some incidents is when your SOC program picks up an alert that's simply OneDrive updating or installing, but it's, connecting to an external domain that it hasn't seen before, that kind of thing. And so it just picks that up, which is kind of frustrating to have to look into. So if you want to look at this configuration, I think it would be really interesting to see some of the typical services and suspicious services that may be started up, commands. Here we've got exclusions of different IP addresses that have to do with Microsoft. So that's like Teams and different Defender platforms and all of that. That's pretty interesting. So let's continue. OS Query. OS Query is an open source tool created by Facebook. Use OS Query with OS Query, security analysts, incident responders, and threat hunters can query an endpoint or multiple endpoints using SQL syntax. OS Query can be installed on various platforms, including Mac, Windows, Linux, Mac, and FreeBSD. To interact with the OS Query interactive console, shell open command and run OS Query I. You'll know that you've successfully entered into the interactive shell by the new command prompt. A sample use case of OS Query is to list important process information by its process name. So select PID, name path from processes where name equals LSAS. Cool. So it gives you process ID, the name, and the path of the process. OS Query only allows you to query events inside the machine, but with Collide Fleet, you can query multiple endpoints from the Collide Fleet UI instead of using OS Query locally to query an endpoint. A sample of Collide Fleet in action below shows a result of a query listing the machines with the LSAS process running. LSAS process, and so yeah, one host is running it. To learn more about OS Query, you may refer to the OS Query Room. And then we have Wazar. Wazar is an open source, freely available and extensible EDR solution which security engineers can deploy in all scales of environments. As mentioned, Wazar is an EDR. Let's briefly run through what an EDR is. Endpoint detection and response are tools and applications that monitor devices for an activity that could indicate a threat or security breach. These tools and applications have features that include auditing a device for common vulnerabilities, proactively monitoring. I just saw a comment. Good morning from US East Coast. Good morning to you. Good evening from me. So these tools and applications have features that include auditing a device for common vulnerabilities, proactively monitoring a device for suspicious activity such as unauthorized logins, brute force attacks, and privilege escalation, visualizing complex data and events into neat and trendy graphs, recording a device's normal operating behavior to help with detecting anomalies. And this is a sample of what it looks like. In fact, in my job, I use a form of EDR known as XDR, which is an extended detection and response. And it looks like very much like this. It does use machine learning in order to learn how the environment, like an organization's environment, functions and normal user behavior, that kind of thing, normal uploads, normal downloads, normal access to things, normal program usage, application usage. So I think is an extended version of this, but it's very similar to what Wazar does. And I think it'd be very interesting to be able to set up this in a home lab. You would learn a lot. Where do the Windows event logs evtx files typically reside? And that was up here. Copy that. All right. Provide the sample, the command used to enter OS query CLI. I'm pretty sure it's just OS query, wasn't it? OS query I. What does EDR mean? Provide the answer in lowercase. Endpoint detection and response. Boom. All right, we're almost at the end. Event correlation. Event correlation identifies significant relationships with multiple log sources, such as application logs, endpoint logs, and network logs. Event correlation deals with identifying significant artifacts coexisting from different log sources and connecting each related artifact. For example, a network connection log may exist in various log sources such as sysmon logs and firewall logs. The firewall log may provide the source and destination IP, source and destination port, protocol, and the action taken. In contrast, sysmon logs may give the process that invoked the network connection and the user running the process. With this information, we can connect the dots of each artifact from two data sources: source and destination, IP and port, action taken, protocol, process name, user account, machine name. Event correlation can build the puzzle pieces to complete the exact scenario from an investigation, and that is correct, because in an incident investigation, you'll constantly need to look at different sources of logs to be able to kind of piece together what's happening. I often get different incidents where we'll have like a connection to an IP or a domain that hasn't been seen before, like in the last 30 days, but there won't be any other information related to that. So then, and that's coming from the firewall. Sometimes the incident will be triggered by the firewall. So then I'll have to go back into the logs and see if where that traffic was coming from was from a managed device. And if it was, whether the agent had captured logs of what the user was doing, which, like, obviously they would have captured the logs. But then I would query and see what the user was doing at that time, have a look at the processes, have a look at if they're running any command line, any kind of scripts or anything like that. And then from there, you can kind of correlate, okay, this connection was made by the browser or by Teams. That's usually like something that happens. And so, but the XDR hasn't seen the IP address that Teams was using, and so it triggers it. Or the firewall hasn't seen that IP address before, so it triggers it. But the only way to be able to figure out that it was Teams that was making that was through checking, two different log sets, which is what event correlation is. Baselining. Baselining is the process of knowing what is expected. That's right. Sorry, I just read your comment. Creating a narrative of the incident is important. Yep, 100%. Baselining is the process of knowing what is expected to be normal in terms of endpoint security monitoring. It requires a vast amount of data gathering to establish the standard behavior of user activities, network traffic across infrastructure, and processes running on all machines owned by the organization. Using the baseline as a reference, we can quickly determine the outliers that could threaten organizations. Below is a sample list of baselining unusual activities to show the importance of knowing what to expect in your network. So baseline. The organization's employees are in London and the regular working hours are between 9 a.m. and 6 p.m. A user has authenticated via VPN connecting from Singapore at 3 a.m. Yeah, that's real suspicious. A single workstation is assigned to each employee. A user has attempted to authenticate to multiple workstations. Employees can only access selected websites on their workstations such as OneDrive, SharePoint, and other O365 applications. And then a user has uploaded 3 gigabyte file on Google Drive. That's suspicious. You shouldn't be doing that. Only selected applications are installed on workstations, mainly Microsoft applications such as Word, Excel, Teams, OneDrive, and Chrome. A process named Firefox.exe has been observed running on multiple employee workstations. Any event could be a needle in a haystack without a good overview of regular activity. And not only that, but you also need to keep in mind the policies and standards that an organization has, like whether organizations are allowed to have a VPN, whether they are allowed to use personal devices, whether they are allowed to have multiple browsers in these examples. You're not just looking for, oh, this is out of the ordinary behavior, but also, is this part of acceptable usage for these employees in this organization? All right, so now we have an investigation activity. We have tackled the foundations of endpoint security monitoring from the previous tasks. Now we will wear our blue team hat and apply the concepts we discussed by investigating a suspicious activity detected on a workstation owned by one of our colleagues. Click the green View Site button in this task to open the static lab and start investigating the threat by following the provided instructions. Oh, that's not what I wanted. I wanted to move. No. Gonna move my face. Cool. Okay, so we have a screen here. Warning, this machine has been compromised. Identify and remediate the threat. Start investigation. All right. Go away. Instructions. Identify the abnormal running process. You may open the baseline document created by the security team. All right, let's have a look. So these are the normal running processes. If you have a look, and we have all of those processes except we have this beacon. That's a malicious process. Based on the identified malicious process, determine the malicious network traffic. You may refer to your notes. So here we have normal connections for SVC host, and we have beacon, and it's connecting to this remote IP, but it's also connecting on a suspicious port. If you've ever done any kind of like pen test practicing or anything, usually you learn to connect on ports like this. When you first learn, later on you realize that that looks real suspicious, so you start using 443. So we have a malicious address. Find all machines affected using the discovered IP address and eradicate the threat. So copy that, paste. So we have a bunch of machines. We'll click remediate on all of them. And congratulations, you have successfully eradicated the threat. You may get your reward from the flag file on the desktop. Endpoint security. All right, now we're up to the conclusions. Conclusion: Congratulations, you have completed the investigation task. In the simulated threat investigation activity, we learn the following. Having a baseline document aids you in differentiating malicious events from benign ones. And not just that, but it's really important to have a good understanding of how core processes work and how it looks normally. Event correlation provides a deeper understanding of the concurrent events triggered by the malicious activity. Taking note of each significant artifact is crucial in the investigation. Other potentially affected assets should be inspected and remediated using the collected malicious artifacts. In conclusion, we covered the basic concepts of endpoint security monitoring. Endpoint security fundamentals tackled core Windows processes and Sysinternals. Endpoint logging and monitoring introduced logging functionalities such as Windows, event logging, and Sysmon, and monitoring investigation tools such as OS Query and Wazar. Endpoint log analysis highlighted the importance of having a methodology such as baselining and event correlation. You are now ready to deep dive into endpoint security monitoring module. To continue this path, you may refer to the list of rooms mentioned in the previous task, which is what we're going to be doing. Congratulations. We did it. This has been fun. So next time, I'm going to be going through this room, which will be good. I'm actually a little bit excited to get a little bit of hands-on stuff, which this looks like. We've got a machine. We're going to be looking at some processes. Cool. Well, thank you for joining me this morning. I hope you enjoyed this video, and if you did, please share it with a friend, share it with someone who wants to learn a little bit more about cybersecurity, and we'll see you in the next one. Bye.